So now that we have summation notation under our belt, we can attack problems like this. But before we get to these problems, we have to learn this thing that's called sequences. And the deal with sequences is that we put in integers into an equation. So when I say integers, I'm talking about whole numbers starting at 1. So when we see a problem like this, there's a couple different ways that we could write it. This kind of looks like function notation, a of n. But sometimes what we'll do is we'll write it like this. So let me write it down this way, a subscript n. So let me, in case you can't understand me, I get it. I don't always speak perfectly. A subscript n. And what it's saying is the first 3 terms. So a subscript 1 means the first term. Let me go ahead and rewrite what this is. Maybe this color. Okay, so a subscript 1 means it's the first term. A subscript 2 means it's the second term, and so on and so forth. So just to kind of skip down quite a bit, if I said a subscript 10, it's the 10th term. And so what you're going to hear me say is a phrase like the nth term. A subscript n means the nth term, depending on what that number is. So when I ask you for a subscript 1, you're plugging 1 in for the n, and then just perform the arithmetic. That comes out to be 1. A subscript 2, the second term, you replace the n in the problem with 2. And then a subscript 3 would be plugging in 3 in for this problem. And what you should notice is there's definitely a pattern going on. If you see it, it would be nice if you see it. It's odd numbers. So when we get back to this problem, and again, a subscript I is saying the ith term, but pretty much is the same thing as saying 1, 3, 5, 7, and we know to stop at 9 because, let me use a different color, if I plug in 5 in for the 5th term, it's 2 times 5 minus 1 gives me 9. And as you recall from the previous lesson, the summation notation tells you to add in there. So this final answer for it would be 9, 16, 25. And what we also have, you might want to hit pause and write anything down or write down any questions that you might have, is recursive definitions. So what does it mean to be recursive? Is we need to know the previous term or terms in order to find the next term. So if a subscript n means the nth term, a subscript n plus 1, you can probably see where I'm getting that from, is the next term. Because it's the n plus 1 term. I know that sounds weird, but if you think about, you know a subscript n. So a subscript n plus 1 is what I'm going to call the next term. So I'm going to try and keep this slow because this generally confuses students. This means we know the first term is negative 2. So the first term is negative 2. If you're confused by that, re-watch the video. Remember I said a subscript 1 means the first term. The word is for the equal sign, and then negative 2. So if I go to a subscript 2, because we don't know that one yet, what I sometimes tell students is think about how n plus 1 needs to equal 2. So in other words, it's a subscript 1 plus 1. So you see how in my formula that's up here, n equals 1. So what that means is that term is equal to a subscript 1 plus 5. And so what I'm getting at is because the first term, a subscript 1, is negative 2, I need to add 5 to it to see that the next term is 3. Let me circle that in purple real quick. Because once you see a pattern, it becomes a lot easier. So think about a subscript 3. So in other words, that's 2 plus 1. Again, I'm just thinking about the next term. So in my problem, that means that n equals 2 now. So therefore, it's a subscript 2 plus 5. N equals 2 plus 5. And the previous term was 3. And there's definitely a pattern going on here. I'll let you think about it, but I'm about to give this to you. Is what I'll say for some students is when you have a recursive definition like this, you're finding the next term is the previous term plus 5. I think it'll make more sense if I start to write out the first 5 terms here, because the first term was -2, the next term was 3, and then the next term was 8. The next term would be 13, because I have to add 5 to it. Notice the pattern. So then the next term would be 18, adding 5 to the previous. And those are the first 5 terms. So what they're trying to get you to do is think of a formula you can get to get a sub 20. So let me kind of jot that down again. We got -2, 3, 8, 13, 18. And just think about, well, it tells you, think about how many times you have to add 5 to -2 to get to the 20th term. Now remember, the second term, because remember that's a sub 2, we only add 5 once. But the third term, a subscript 3, we have to add 5 twice to -2. What about the fourth term? We have to add 5 3 times. And the fifth term, so you add 5 4 times. So the thought process is, and this is actually the right formula, is from -2, you have to add 5 for the 20th term. You have to add 5 19 times. So what I'm going to do is just go to the calculator. Instead of doing -2 plus 5 19 times, oops, totally missed that one. What you can do is do -2 plus 5 times 19, and you'll get the correct answer of 93. Feel free to think of other ways to get that answer, but that's the overall thought process there. The next one is a little bit different, but they want you to practice coming up with a recursive definition. And anytime you come up with a recursive definition, you have to give the first value. So anytime you're given a recursive, you might want to write this down. You have to give me the first term, and then you have to give me the next term. So the first term in this problem, I hope is really easy for you, is 5. And so the next term, what you have to do is think of a pattern to get from one number to the next, and it has to be the same pattern over and over again. And I hope you can look at this and see each one of these is multiplied by 2. So to write the next term, you can just take the previous term and multiply by 2. And that is what we're looking for. I know this isn't the easiest, but I don't want to over-explain something in a video if that made perfect sense to you. So this next one, very similar. We know the first term is 2. Okay. Now this is a recursive definition, but the difference with this one is they give you the nth term, and then they give you the n minus 1 term, which is confusing. I get it. But what I'll say to some students is if you're looking for the current term, that's still the previous one. And let me try to explain this a little bit better. So if you need t subscript 2, you have to plug in 2 in for n, and just think about what 2 minus 1 is, that you're going to square it and add 2. Well, 2 minus 1 is 1, t subscript 1 is 2, so it's 2 squared plus 2. I think you can do that math in your head to get 6. But that's not what we want. We want the fourth term, so we got to find the third term. T subscript 3 minus 1 squared plus 2. So that would be t subscript 2, which was 6. Maybe I'll even circle it and move it down here. It's squared plus 2. So that's 38. Not quite done, though, because we're still looking for the fourth term. And again, n is 4. And I don't know what 38 squared is in my head. That's why I let you use a calculator. I'm pretty sure the correct answer is, yep, 1446, option 4. A very large number. All right, I think I need to speed things along to get to this next one. So there's something called the Fibonacci sequence, and basically what it shakes out to is it's a recursive definition, but it uses 3 of them. So this time we have to know the first 2 terms, and the whole thought process is the third term. So if n is if we're trying to find the third term, n would be 2. So it's a subscript 2 plus a subscript 1. Same thing with the fourth term. It's going to be the third term plus the second term. Same with the fifth term. It's the fourth term plus the third. So I'm going to go ahead and write out the first. So basically, to get the next term, you add 1 plus 1 is 2. To get the next term, 1 plus 2 is 3. The next term is 5, 2 plus 3, 8, 13, 21, and we can explain this a little bit more in class, but that's the Fibonacci sequence. So it is a recursive defined definition. With the next one, instead of coming up with a recursive definition, they want you to come up with your own formula, and there are, I'm just going to write out a few of them, and like this first one, you can see that there's a pattern that we're adding 1 each time, but instead of writing a recursive definition, they want you to write out a formula. So this formula would be n plus 3, and what happens there is I'm plugging in 1 in for n, and I need to get the first term is equal to 4, and 1 plus 3 is 4. The fourth term would be 7. 4 plus 3 is 7. And it gets trickier from this, especially when I look at the next one, because it's multiplying. It's going to be 2 to the nth power. And you can double check that that works. This next one is really tricky because it's the 5 is always on top. I don't like how I wrote it, but no matter what, 5 is on top, and if you plug in 1 in for n, 5 divided by 1 is 5. Plug in 2 for n, the second term. And these are pretty tricky. I don't want to just give you all the answers right away. I want you to think about it. This one, though, is going to be -1 to the nth power. And think about how we alternate signs with odd. If we have odd exponents, we get negatives. If we have even exponents, we get positives. This next one, I'm noticing a pattern that it's going up by 5s, but if I plug in 1 in for n, that's not going to give me 10, so I better add 5 to that. I know I'm just giving you answers, but we're going to come up with a methodical way of doing this. The next one, I notice that we have perfect squares in the denominator. I don't know how many of you could just look at that problem and know that's the correct answer. But we'll think about it in class, and hopefully you can write down your questions and bring them back to class. On this last question, they want you to realize that we basically, our domain of n values are going to be integers, positive integers. And so the thought process here is we don't want the lines in here, because as far as like a sequence goes, we don't want the decimals in between. It's okay to get a decimal result, like if this number, that number was a decimal, but n cannot be a decimal. But I think in all of the problems we work with, that's going to be a positive in it. Well, it can be negative as well. But let's not get into the semantics of that. So the problem with this one is n can equal 0. So we don't want that one either. The correct answer is option 3. If that was confusing, again, just write down your questions and bring them to class. That's what I want. I want to have that discussion. But you should be ready for this homework at this point.